solve problem number 15, which is a problem of solving limits algebraically. When we have a limit and x approaches a, you need to know that if you need to substitute a in the x if it's p times x over q times x. So you need to substitute a in x. The problem I chose was the limit as x approaches 5 of x squared minus 25 over x squared minus 2x minus 50. To solve this problem, first we need to factorize. We need to check first if we plug in 5 here and the answer gives us 0, we need to factorize. If it does not give us 0, that's the answer. So we plug in 5 in the equation and it's 5 squared minus 25 over 5 squared minus 2 times 5 minus 15. This 5 squared is 25. 5 squared is 25 minus 2 times 5, which is 10 minus 15. Around there is 0 over 0. So now we need to factorize to factorize this equation. First we factorize the numerator, then the denominator. To factorize the numerator, we get the rule of squares, which is x plus 5 times x minus 5 over. To factorize this lower equation, what we should do is find a number that multiplied gives us this times this, which is negative 15, and added gives us the number in the middle, which is negative 2. So 5 times 3 is 15. And 3 minus 5 is negative 2, so the 5 would be negative. So here in the denominator, we should put x minus 5 and x plus 3. Here, we can now cancel both of these numbers, x minus 5 and x minus 5 from the denominator. So our equation to find the limit as x approaches 5 would be x plus 5 over x plus 3. Now, we should substitute the 5 as an x in this equation to get the limit. So the limit would be 5 plus 5 over 5 plus 3, which is 10 over 8. And this fraction simplified by 2 would be 5 over 4. And this would be our final answer. See. So now we know that as x approaches 5, the limit is 5/4. In the graph, we can see it here as we go to 5 on the x-axis, and our y-axis would be around 5/4.
The basic rules of differentiation is number 1, when f of x equals to kx n exponent, and then the derivative is n kx and then n minus 1, and then the second one is when f of x equals to kx and then the derivative equals to k, and then the third one is when f of x equals to k and then the derivative equals to 0. When k is any real number, it doesn't equal to 0, and then when n is any real number, like you have to do those equations, like those are the rules. And then and then when f of x equals to un, then the derivative is n times u, n minus 1 exponent, times u, 1 exponent.
The equation we're going to use for differentiation is this one, and first we're going to find the derivative. First is, from the rules, we know that we multiply the exponent times the coefficient, and then the exponent of the x, we subtract 1, and it's 2 minus 1. Then, minus, when it's a number x, we eliminate the x, and then when it's only a number, it's 0. Then, plus 0. Then, we solve it, and it's 4x1 minus 5. And this is the derivative. To find the slope, we are gonna this equal it to this, no otra vez. Okay, now to find the equation for tangent line, we're gonna use this number, and for this, the formula of slope is mx plus b, y equals mx plus b. So, for the derivative, we are gonna plug in the 2, and it's m equals 4 times 2 minus 5, and it's m equals 8 minus 5, m equals 3. Then we know that the x equals 2 and the y, it's the original formula. We plug in the 2 and it's y equals 2 times 2 to the second power minus 5 times 2 plus 1. Y equals 2 to the second power 4 times 2, 8. X minus 10 plus 1. Y equals 8 minus 10 is negative 2 plus 1, negative 1. And now we're going to find b. And it's y minus 1 equals 3 times 2 plus b. And it's minus 1 equals 6 plus b. And then is b equals 7. So the formula will be y equals 3x plus 7. So the final equation will be y equals 3x minus 7.